Oh.
Good afternoon and welcome back to METALCON Live. I'm Judy Geller, Director of METALCON, here with Kaylin Burke at the controls today. It's great to be back after hosting a terrific METALCON show in Tampa last month. Despite all the challenges due to the pandemic, I think I speak for everyone who was there when I say how great it was to be together live and in person for such a successful and high energy event. We left feeling really charged up, good about the event, and excited to start planning METALCON 2022. But today, we bring you one of the hottest educational topics we held at METALCON this year, the fundamentals of Rainscreen, presented by Steve Gaynor, President of Pivot Corp and Vice Chairman of the Rainscreen Association in North America, also known as RAINA, is here to present the topic today. Also, be sure to mark your calendars for our next METALCON Live, which will take place on December 8th at 1 o'clock Eastern Standard Time. It's going to be another hot METALCON topic, growth of solar and the emergence of net zero construction. Our presenter on the 8th will be Dan Javin. He's the CEO of Suntuity. Also, pre-registration for METALCON 2022 is now open. You can pre-register through the link that we've put here in today's chat, and we do hope to see you in person in Indianapolis next October 12th through the 14th. And finally, just a quick reminder that if you do need technical help, reach out to METALCON support in the chat box, and don't forget to complete your post-webinar survey so you can earn your AIA LUs for today's session. And now, without further ado, I'm going to turn it over to Steve to take control of today's session.
Okay. Grab the screen here. Thank you, Judy and Kaylin and METALCON. I'm glad to be here, and I had a great time in Tampa. It was a fun event. So we're here today to discuss the fundamentals of Rainscreen wall design. The title of the presentation is "It Takes a Village," and there'll be also an introduction to the Rainscreen Association and what we're doing at the end of this. Please remember to, if you have any questions, please put them in the chat box, and we'll get to them at the end here. Let's get into it. This presentation is available for continuing education credits, and we can discuss that later towards the end of the presentation if you need those. We're here today to talk about Rainscreen, and really the theme that you'll hear over and over again is that this is a holistic thought process to think about the whole system, right? So we start out saying, no single person can really ensure that that the building performs as designed. It takes a lot of different materials, different organizations, and different stakeholders throughout to do that. And moisture damage is one of the leading causes of problematic issues in buildings. And as we design with more and more tighter controls, those moisture issues are going to become more and more in the forefront of the conversation. And so, we're going to talk about Rainscreen, which is considered to be one of the gold standards for wall design. And the issue, though, is that Rainscreen is not well understood, maybe even by some of those people who talk about it often. And one of the reasons why is because there's a lot of different people talking about it, and not a lot of coordination. And that's why we'll get at the end to talk about how it takes so many stakeholders and why the Rainscreen Association was formed. So the learning objectives for this presentation are to identify the most common reasons for moisture problems in wall assemblies, compare the differences between a Rainscreen and a barrier wall, Then we're going to identify key components in the Rainscreen assembly and some considerations for each of those components within Rainscreen assemblies. We'll get a little bit further into the impact of thermal bridging. You should be able to discuss sort of what those issues are with thermal bridging in building enclosures and how Rainscreen assemblies can be designed to mitigate that impact. So we'll start with moisture in walls, get into those components. As we talk about those components, we'll have a deeper dive into the thermal bridging discussion, and then we'll talk about the Rainscreen Association North America. So starting with moisture, you see here two section details of basically a floor line at ground level. On the exterior, you see a cladding, which looks like a brick cladding, and then a cavity there, a basic stud wall assembly, a flooring assembly, and then a below ground assembly. And on the left-hand side, you're looking at how water gets into an assembly, right? So number one, everybody knows precipitation. You're looking at that hitting the exterior cladding, and that will either drain off or also be absorbed sometimes by the exterior cladding. Number two, you're looking at vapor diffusion. So vapor diffusion is caused either by, let's say, that exterior cladding takes on some of the water, and as it evaporates, it causes some vapor pressure, and that goes, both in and out of the wall system. And vapor is also, or vapor diffusion is also comes from the inside of the buildings, right? So either through human activity or otherwise, we're creating water vapor, and that tries to get out and will go into the wall system. Or you have some built up moisture in your construction materials. Concrete is the mostly what everybody knows in terms of having to manage that as that's curing. And then you have other sources like groundwater and those coming in through through basements and things like that. On the right-hand side, you look at all of the ways that water is evacuated from the system, right? So we take a look. Number three there, I think, associates with precipitation, right? If we're getting rain, we're seeing that drain, right? The liquid water is draining either by shedding off of the face of the cladding, or if it gets into the cavity, going down to whatever drainage or hopefully weep holes we have to evacuate that liquid moisture. As that liquid evaporates, it creates water vapor. And so you want to evacuate that through ventilation and drying. You see number four there, through air exchange with the exterior. And then number two, you also have water vapor diffusion occurring in your favor, right, for drying out, and it can be designed to do that also. So we'll get into a little bit more about that as we go on with these next few slides. What you'll see here is three approaches for wall designs in terms of controlling, specifically regarding controlling water in walls. And you'll see here that there's labels at the bottom of these different pictures that talk about materials. Those are there because those materials are typically done in this fashion and typically fall into these categories. But with different designs, those same materials can be used in other designs, and we'll get into that later on. So don't get stuck on those materials at the bottom there. But the first category here is storage, and this is typically mass walls. You see a lot of this in Europe, where you're building with stone walls with cement or concrete, heavy masonry walls. And what storage means is that these walls can absorb a certain amount of moisture as they're shedding moisture, and not cause many problems in terms of leaks. The second is exclusion, and this is what we're familiar with most over the last 100 years or so in the U.S., which is designing wall systems to keep water out at the face of the wall system. That's things like structural glazing, and that's probably the best example of what exclusion is. Is that, you know, when we look at a glazed wall, we see the glass, we see the frame, we see all the seals around it and seals around the frame, and that's all designed to keep water on the very face and have it drain off of the face of the wall. Now, those seals obviously have to stay perfect over time in order for you to maintain that perfect barrier and avoid water into the wall system. But you know, some of these other wall designs that we're familiar with have the same intent, right? To keep the water on the face of the wall system. And then finally, you have your drainage wall systems, and this is where Rainscreen fits in, right? So you have a much broader category that is, you know, that's beyond Rainscreen in terms of drained wall systems, but Rainscreen is one of these. And what a drained wall system is saying, okay, that cladding doesn't need to necessarily resist 100% of the water that's coming to the wall system, or the face of the wall doesn't need to resist 100% of the water. We're designing the wall so that water that gets in can be drained out, and we're managing it in a different way. And so we'll talk a lot about that in the coming slides here. Just to look at this from a sort of a flowchart standpoint, what you're looking on the left-hand side of your screen there is the perfect barrier, and that would be that middle section, that exclusion design, right, where we're trying to keep everything on the face of the wall system because we've sealed it and we want to keep it perfect. The issue with that is that you need to keep it perfect over time in order for the wall to perform properly. And then you see what we're calling the imperfect barrier, and there's a lot under that. And let's start with the mass or storage wall. That was the category that you first saw on the last screen with the concrete and thick masonry and so on. And that's the reason why that's, you know, an imperfect barrier is because it allows some water in and maintains, you know, water control by storing that water and shedding most of the water, you know, so you don't have leaks. And then finally, where Rainscreen fits in is in drained and screened walls, and that's that third design where you're creating a design that is intended to manage the moisture within the wall system through venting, ventilation and pressure moderation, etc. So, what is a Rainscreen? A Rainscreen, as defined by the Rainscreen Association of North America, is an assembly applied to an exterior wall which consists of, at minimum, an outer layer, an inner layer, and a cavity between them sufficient for the passive removal of liquid water and water vapor. I will not repeat that on this slide because I'll repeat it the 5 more times it appears on the next few slides as we go deeper into this definition. So again, the Rainscreen Association of North America has defined Rainscreen this way, and it's the simplest way to say this is what constitutes at minimum a Rainscreen. And what you're looking at here is the definition above and the parts of the definition described in the diagram below. So again, an assembly applied to an exterior wall system which consists of, at minimum, an outer layer. You see on that diagram to your right, you're looking at a vertical section of the wall. You see it on the left, it's a plan view detail. On the right is a vertical section of that same wall. A simple, you know, very rudimentary Rainscreen design having an outer layer, the number 1, which, you know, is your cladding or some other face. An inner layer, which is typically your water barrier or some water control layer that might be insulation or some other system. And then a cavity between them, which is number 3 there, sufficient for the passive removal of liquid water and water vapor. So number 4 and 5 shows, you know, drainage and venting for the passive removal of liquid water and water vapor. That's it. That qualifies as a Rainscreen. Obviously, there's more to making a high-performance wall system than qualifying for the bare minimum of a Rainscreen, and we'll talk about that later. But that is the explanation of the definition. It's important to note that almost any cladding material and almost any backup wall separated by a cavity that is drained and vented or ventilated can become a rain screen, right? So even though you might think of materials that are typically used or in the past have been used in a certain way, often we can redesign those wall systems to use rain screen principle and design a rain screen. So it's not beholden to any particular material. And it's important to note, not only is it not beholden to any particular material, but it's about the system coming together as a whole, right? It's not the cladding, it's not the the backup wall, it's the cladding, the backup wall, sometimes insulation, etc. And that's what this slide is about, right? This is saying, okay, we have different kinds of wall designs that qualify as rain screens, and we have different buildups within the cavity that might occur, but that doesn't mean that we're veering away from rain screen design. To get further into that, we provided a little diagram here to go from sort of one end of the spectrum to the other end of the spectrum. And what I like about this diagram is that each of these wall systems are using a metal cladding, right, to show that a metal cladding and stud wall design to show that just with a different geometry and slight modification, we're moving from one design to the next. It has very little to do with the materials themselves. So under the not rain screen section on the left-hand side, you see your barrier walls, like we talked about before. Typically, your sealed walls. What we're trying to do is keep them on the keep water on the face. Also under that section is your purely drained walls, and there are walls designed without venting or ventilation that are designed with drainage, and that might be for the purpose of insulation, etc. There's functional performance reasons to do that, but those don't necessarily qualify as rain screen walls. Then the dividing line there, you start with drain and vented and drain and ventilated walls, and these are the rain screens that you typically see with your rigid panel systems. And then all the way at the other end is pressure moderated, pressure equalized walls, where you're creating small compartments. It's a highly engineered system to moderate that pressure and keep water, manage water tightly towards the face of the cladding. That's the spectrum there, and we'll get further into some of those designs as we talk about components later on in the presentation. So, like we said, at minimum, rain screen includes that outer layer, that air gap, that inner layer. Obviously, there's a backup wall, there's flashings and other openings for drainage, but that's what's required. However, there are other components in a rain screen wall for different designs and functions. Some of those components might be a cladding attachment, obviously. You need to figure out some way to keep that cladding up on the wall, and that cladding attachment has some other functional purposes that we can talk about. Exterior insulation. More and more, we're seeing exterior insulation because it's required in most of the country, and that's going to often be in that in your rain screen wall. That's insulation outboard of your exterior sheathing. Now, we said that there's an outer layer and inner layer, and that inner layer is typically your water control layer. But that you might also have an air barrier in the rain screen system somewhere, right? And that air barrier might also be your water barrier, right? So it could be separated, it could be the same thing, depending on the design and the needs of the building. Same thing with a vapor barrier. Less common to see the vapor barrier on the exterior, but it also might be there. So let's get into those components a little bit. Now that we've defined what is a rain screen and all the things the components that might be in a rain screen. Let's start with cladding. That's what everybody sees when they see rain screen. Often people confuse cladding to mean rain screen, right? They might say, that material is a rain screen material. which is, as we've discussed, often incorrect because Rainscreen is the whole system together. But almost any material, as we've said, can be a cladding in a Rainscreen. And it's not just these ones that you've thought of. The Rainscreen Association is even working with the stucco industry on guidelines for Rainscreen designs using stucco and stucco materials. And that just goes to show you that it really is about the principle rather than the material. The important thing for cladding is that they're an exterior finish, that they're water shedding, and that they are unprotected from the environment. That's usually what defines the cladding. There's a lot of considerations with cladding. There are a lot of different claddings out there. We'll talk about the design considerations in a little bit, but there's also these other system-related considerations at the bottom of your screen. One of those you see in red is that deflection criteria. So you might be designing your Rainscreen with a metal system or a composite material that's able to deflect a fair amount, and those sort of things are designed into not only the panel but the system and the rest of the wall. The same thing if you're designing with something like stone or porcelain that is much more rigid. You're thinking about the rest of your wall system in terms of the way that it has to be designed to achieve that deflection criteria. Cavity or your airspace, your gap, what have you. We have to think about this as a component. This isn't just something that we're leaving, just empty space, right? We are creating this component when we design a Rainscreen, and we're creating it when we're installing a Rainscreen. So, one of the things that I often tell contractors when we're doing trainings is that you're treating the cavity as a component, just like anything else you can hold in your hand, that you want to make sure that component's in there when you're doing modifications, alterations, things that aren't necessarily on the drawings, decisions that you have to make in the field. This cavity is an essential component of a Rainscreen. And some of the things it does is obviously it allows for drainage and airflow. It inhibits capillary action. On pressure equalized designs, the cavity is, and the geometry and design and the way that we compartmentalize the cavity is of utmost importance. But it has also other considerations like when we're talking about smoke and fire propagation. The cavity also provides us with additional functions, right? So if you look at a face sealed barrier wall system, like we said, it has to be perfect. You're keeping that water on the face of your system. The only drainage plane you have is that face of your system. With Rainscreen, because we're putting that cavity in there, because we're separating out the different layers, because we're looking at this as a whole system, you have multiple drainage planes. So not only do you have the face of the cladding, but you have the back of the cladding, you have the face of the insulation, and finally you have the water resistive barrier. So you're creating 4 drainage planes. And anyone who's had the opportunity to perform an AMA 509 test and stand in that box and watch as your Rainscreen performs, watch behind the Rainscreen and watch where water goes. You'll be amazed to see water drain down the back of that cladding. Then the cavity also gives you the opportunity for venting and ventilation, right? So you create vents. What you're looking here on the left-hand side of your screen is a diagram so that we can show both the bottom and top termination of a system and how they might differ depending on the different designs, right? So this is a section view of the wall. You're looking at a drip edge here that's going through your cladding for one reason or another, and what you see here on the left-hand side of the screen is a typical design for what they use in pressure equalizer, pressure moderated systems, where you're creating a vent at the bottom of the wall system and allowing that to be your drainage and for your air exchange and also for your pressure equalization. You're typically sealing the top of those systems. So that would be a vented system. On the right-hand side, it shows what would typically be considered a ventilated or a drain and ventilated system for a rain screen. And that's showing that you have both openings at the bottom and the top of the system. So at the bottom of the system, you have your liquid drainage. And then at the top and bottom of the system, you're creating space for air exchange and that airflow. One of the nice things that you achieve with both top and bottom ventilation is that stack effect to create that passive airflow through the system. Now moving beyond the cavity, we have our water resistive barrier. And this is what we were calling the inner layer in that definition, right? And the water resistive barrier might not be a membrane, right? We all think of membranes when we talk about water resistive barriers. It might be a system, it might be included in your insulation, it might be some other system, but whether it's a membrane or whether it's another system, your water resistive barrier is an integral part of your rain screen. And it has its own considerations, right? So often when I was helping architects a long time ago, trying to design wall systems, the question was whether you're going with fluid applied or sheet applied. But now there's so many more options, and they end up being specific to what you're trying to do in your wall system. One of the things that's very common to talk about these days when we're talking about the water resistive barrier is penetrations by the cladding attachment components in that water resistive barrier. Obviously, we need to attach things outside of the sheathing, and that attachment means that we're going to have penetrations in the water resistive barrier regardless. So the question is, what do we do about them? Manufacturers have tons and tons of guidelines around those. Contractors are trained to address those. There's a lot of consultants out there also helping to address those. But the Air Barrier Association, one of the partners for REINA, is also working on this issue for these water resistive barriers, and I know that several other organizations are part of that discussion. So this is something that I think we're going to see some science-based literature on in the near future here to see how much of a problem that really is, if it's a problem at all, and how to address those things. Cladding attachment systems. We just talked about the penetrations by cladding attachment systems. What you're looking at here is just some diagrams of different types of cladding attachment systems, and they really range from adhesive to sort of high performance structural systems with lots of components. What you're looking at in the middle is what I grew up with, which is basically just metal girts as the only cladding attachment system for a number of decades until the thermoperformance conversation really took over. Getting into thermal bridging. Yeah, thermal bridging occurs when a conductive material provides a path for heat to bypass installed insulation, reducing the overall effectiveness of the entire system. And that's where we talk about effective R value. So effective R value is when we're talking about the overall effectiveness of the entire system. So an insulation might have an R value, but when you put it into a wall system like you see on the right here, you might have studs or other penetrations that reduce the effective R value of that insulation. I'm not going to get into this too much here, but obviously many of you who are more adept at identifying thermal bridges can find many more than me here. But these are a couple of examples of some obvious thermal bridges in the columns and slab edges, in the attachments, etc. Adding insulation to within the wall system, like we traditionally did, provides diminishing returns. You can imagine, so if we had a typical wall system as we used to build with a stud wall with bad insulation in there, let's say that R11 bad insulation with a typical 16-inch stud wall, that insulation ends up having an effective, or that wall system ends up having an effective R value of 6.6 when you're putting, an R11 bat in there. And so if we're looking at that, we're saying we need more, higher performance out of our walls. Well, the obvious first thing to do is to put more insulation into the wall system. And as you put more insulation into that part of the wall system, you still have those studs to deal with. So going from an R11 to an R15, so that's a additional R4, really only gets you an effective R value of just over 1 increase, and that shows you why exterior insulation is really where the conversation has revolved around. So we're looking at exterior insulation that's outboard of your sheathing. You start to see that if we can create exterior insulation in a perfect environment where it doesn't have penetrations around the outside of your stud walls, you're really gaining a lot of effectiveness into the insulating value of your wall system. However, as we know, we need to put some things through that insulation, and the traditional way to do that was with those metal girts that I grew up with, right? So when we first started to have this conversation about putting exterior insulation on the exterior part of your wall system, the conversation started with, yes, let's put more insulation on the exterior part of your wall system, and and we'll put those metal girts through it because we need something structural to attach everything outside of there on, and that way we have a lot of insulation and a structural wall system, and we're good. The problem is we've just moved that problem of the stud wall system out, right? And so so the industry has come up with a lot of innovations to reduce the effective value, or the impact on the effective value of those attachment systems. What you see here is a lot of different examples, and there are more out there, of different designs in the industry of attachment systems that have moved their continuous rail out, sometimes outboard of the insulation, or at least towards the edge of the insulation, and put non-continuous components through the insulation to really reduce the impact on the effectiveness of the R value. So let's back up a little bit. Like I said, when we first started putting insulation on the exterior walls, we started with, let's just use the same technique we were using before with bigger girts, and stuff insulation between those. And if you're putting a vertical girt aligned with your vertical stud, you're really getting a 20 to 40% of the effectiveness of whatever insulation you're putting in there. And that's obviously better than not having it there, but it's wasting a lot of money and a lot of space in your wall system. As you move those horizontally, yeah, you get better, right? If you have horizontal continuous girts going through your insulation, you might get 30 to 50% of your effective R value, or of the intended R value for whatever insulation you're putting in there. And also putting things horizontally, you have to show more attention to detail because of water migration issues and so on. So, like we said before, the industry has come up with a lot of innovations, and they are continuing to come up with innovations for addressing these sort of things. You've seen clip and rail systems like the one on your screen, and what that does is it takes non-continuous components, it puts those in the insulation, minimizing the amount of metal that has to go through the insulation for structural value, and then putting any continuous components as far out on the insulation as you can, sometimes completely proud of the insulation if you can afford that space, giving you the best values. Also, you see solutions where we're either using non-metal components to reduce the effect of those bridges. And then you see full girts that are non-metal in certain situations, to make sure that you have no screws going through that insulation. And finally, you also see attachment systems where you have only screws going through the insulation and no girts or larger metal components. And these are all designs that are available out there and have pros and cons that might be appropriate for a certain project situation. So there are a lot of considerations when you're talking about the attachment system, and designers should be looking to manufacturers, and manufacturers should be training their installers to be identifying these considerations throughout the process. Energy code compliance is one of the major considerations out there, but there's also things like fire and durability and structural performance that need to be considered, specific to project needs. Exterior insulation, we've talked about it on probably more than half our slides, but we haven't talked specifically about the exterior insulation and the considerations around that. Typically, there's a few different materials that you might consider for your exterior insulation, and those materials come with pros and cons themselves. If you're trying to have a vapor permeable wall, you might go with one type of insulation. If you're trying to really seal up your wall, you might go with another. And then fire and other moisture issues might come into play when you're deciding whether to go with something like a mineral wool or a foam plastic. One moment. Another thing to consider with exterior insulation is installation guidelines, and this is something that every manufacturer provides, but often when we're trying to do things like reduce thermal bridging, or maybe even if we think we can design a system that holds in the insulation that's like a Z-Girt system here that you see, you might see some variation that leads to, well, what I assume was a perfect wall last night that is now on the ground this morning because those ties that appear to be in there weren't tied back to the right places. Design professionals have a lot to consider, when it comes to Rainscreen. They also have a lot to gain when it comes to Rainscreen. Rainscreen has a lot of flexibility because you can use multiple materials, often on the same systems, backup systems. So you don't have to change, from one to the other when you're thinking about the performance of your wall system. You can have the same high performance and mix materials, or have depth and things like that to your wall system. They do have to consider, structural loads, environmental loads, things like fire and UV and other considerations specific to performance of whatever materials you're using for your project, right? Those things, those parts of the cladding or of the material are important when you're considering how it's being used on the rest of the project. So if you're building a low-rise building in someplace where you have lower wind loads, you have different considerations than if you're building a high-rise in the middle of a congested city. There are a lot of tested metrics out there to determine if the materials are appropriate for use in certain situations. And most of your manufacturer guidelines have a great list of, manufacturer specifications have a great list of these standards specific to the materials that that they're supplying. What you don't see a lot of is system tests, right? So you see AMA 508 and 509, and if you hadn't have an opportunity to witness that, I'd go on to YouTube and see a few of those. Those are come close to system tests. They really test the design of cladding in a certain certain attachment configuration. And then you have NFPA 285, which I think most people are familiar with, and the fact that that is a system test that not only has to do with the materials that go into it, but also the geometry around the way those materials are put together. Here's some background noise. Please forgive me. I am in the middle of New York City, and anything can be outside. Contractors have their own considerations when they're looking at rain screens. Obviously, the rain screen should be already designed for them, and they're working off of a set of shop drawings that either they've created or some manufacturer or channel partner has created. And they have to make decisions in the field around things that maybe aren't drawn or modifications that are made to the building. One of the really important things that contractors have to take into consideration is the expansion contraction materials and how they're putting up those materials that go with that are adjacent to each other. Those sort of things like those sort of things are designed into the system with often manufactured into sliding and fixed holes, both on your panel systems and components beneath that, and contractors have to pay attention to where those are to create high performance, long durability systems. You do have a lot of requirements for rain screens that in the code, but they're not specifically called out for rain screens in the code. So you start with material. You see all these materials that are listed in the Chapter 14 of the IBC. They all have requirements in Chapter 14 of the IBC. We typically don't adhere strictly to them because we're going beyond that with these high performance systems, not going with the prescriptive method, often going with the engineered or calculated method. So Chapter 14 does reference other chapters for fire and structural performance, specific fire tests, specific material qualifications, and prescriptive methods to use the material. Chapter 14 doesn't reference energy performance of assemblies. You have that in Chapter 13, then the IECC, which references ASHRAE, and you have to get into that. But it's not specific to the assembly, to the full assembly. You have, water performance isn't specifically addressed. Assembly design with thermal movement, requirements for materials not specifically listed. Right, the code is on a 3-year cycle, and that 3-year cycle takes a long time to get new materials and new methods into the code. And rain screens are not currently in the code, although the Rainscreen Association is trying to change that. It's important to note, there are a lot of methods or a lot of requirements for materials in the code. There's not a lot of requirements for systems in the code, and so when we're designing high performance systems, we're typically not going with the prescriptive requirements, but we're going with those performance or engineered requirements, and that goes to engineering like seismic engineering, but it also goes to calculated U value and NFPA 285 system tests, and also engineering judgments around those, and then deflection limits. Now this slide says compliant walls might lead to a lot of problems. And that's just, again, to say that the IBC and code requirements are often the bare minimum of what we need to do to get to compliance. That doesn't necessarily mean that materials that have been tested will work together to prevent leaks and cracking, et cetera, et cetera. And we really need to have a more holistic view of systems when it comes to exterior wall systems. That gets right into the Rainscreen Association and what we're doing at REINA. So let's talk a little bit about REINA and the Rainscreen Association and why we're here. What you see here is a pretty sloppy sandwich, but hopefully tasty. And what makes it tasty is the different layers working together. That's the same thing with a Rainscreen Association. With the Rainscreen assembly, is that we have different layers working together to create that final assembly. And not only do we have those different layers, we have those different materials, we have different suppliers, installers, we have all sorts of stakeholders throughout the process. It's going to be your design, the architect and design professionals, consultants, testing agencies, et cetera. And right at the center of this very confusing Venn diagram is where successfully installed high-performance multifunctional Rainscreen assemblies live. Right, that's where everything comes together and you get that really great wall assembly. So that's the thought process when it comes to why REINA was put together. We have 94 member companies, and that means hundreds of individual representatives from those companies serving within REINA. You see a lot of companies that you recognize, but it's important to note that these are not manufacturers. In fact, most of the membership for REINA is not manufacturers, and that's designed that way. It's really intended to be a collaboration between the stakeholders to get to holistic thinking for how we get better buildings through systems thinking and Rainscreens. See a lot, more brands there. Again, this is a quick view of our 94 member companies broken down into the different categories. You see less than half of those are manufacturers and major manufacturers and material suppliers, and we have an initiative to increase that over the next few years. REINA's vision is to be the recognized Rainscreen authority supporting performance-driven Rainscreen assemblies that contribute to more durable, resilient, healthy, energy-efficient, and safe buildings. Our mission is to work together with our membership, industry, and trade to be the recognized authority in Rainscreen wall assemblies in North America. That's to house everything in terms of knowledge base under one roof, so that we can share and make sure that all those things work together. Our values are integration of expertise, building science-based performance criteria, sustainable, long-lasting building enclosures, and obviously, we keep design aesthetics as a priority. Also, it's important to note that we are not looking to reinvent the wheel here. We are not looking to take on things that other organizations have taken on and done great work at, right? So what we want to do is we want to take the work that's been done in other parts of the industry and bring those together and say, okay, how does what's been happening at the Air Barrier Association match with what MCA has done with claddings and geometries there? And can we get those different guidelines together and come up with a more broad, holistic guideline that references both of those? In fact, the Air Barrier Association is a formal partner of the Rainscreen Association for just that purpose, where we want to keep that expertise where it is. We've worked with FGIA on the AMA 508 and 509 during their revision process, and we have input from the technical building knowledge committees under the AIA. We also have communication with the international ventilated facade organizations. This is what REINA looks like in terms of an organizational chart. It's seven formal committees that report up to the board of directors and the executive committee, and all of those committees serve the membership, right? So the board of directors serves the membership. The board of directors is directly elected by the membership, and that's the purpose of this all. You see those 7 committees are our building codes committee, working on codes and code changes and communication with other standards organizations. Our definitions committee, our diversity, equity, inclusion committee, education and training, industry outreach and marketing, Rainscreen performance, and our residential committee. REINA's 2030 vision is to be the true North American coalition. That means United States, Canada, and Mexico, and we are already significantly working towards that. We will be an accredited standard development organization. and that allows us to have our guidelines go directly towards codes and standards that you're familiar with. We want to have the majority of active and growing membership to be contractors and architectural firms, because that's really where the rubber meets the road in terms of making Rainscreen work and better buildings. And REINA will be the center of excellence for all things Rainscreen. Industry and regulatory bodies will look towards REINA for guidance and participation. Our highlights, again, we already talked about it. We have over 94, we have 94 member companies right now on hundreds of representatives from those 94 member companies serving on 7 standing committees that are creating work based on work plans and have their own independent budgets. We have check out the website for REINA that was developed last year and is becoming more and more functional for work within the committees. And then we also have a technical bulletin that was prepared by the Performance Committee, and you saw a few things taken out of that technical bulletin as part of this presentation. Check out the website, and that's the end of the presentation here. I'm interested in hearing what questions have come up, Caitlin.
Yep, we actually do have several questions that have come through. First
Okay.
of all, I will let everyone know that the recording will be available on our METALCON Live YouTube page before the end of this week. And we do have a few questions regarding what to look for when commissioning a wall system, Steve.
What to look for when commissioning a wall system? I think, yeah, the key for me, well, obviously certification for whoever's doing the commissioning, but the key for me is that holistic thinking, right? And that's the whole reason why you commission a wall system, is because it's someone who understands that a wall system is a system on its own, and all the decisions within it are not isolated to materials or suppliers, but they all work together. So it's about choosing the functional design, whether you're creating that barrier wall system or a Rainscreen system, and then sticking with that for your whole design process.
Great. Someone else has asked, will the slide deck be available separately from the recording? So can we share that with our attendees today?
Yes, I think we can make the slide deck available.
Okay, thank you. We'll make sure that all attendees receive that at some point in the future. No guarantees on time though, everybody. I do not have any current questions listed here. Does anyone have any last minute questions for us? Okay, I'm not seeing anything come through. I'm not seeing any typing. So I will say thank you very much, Steve, for joining us today on our first METALCON Live back from METALCON 2021 in Tampa, Florida. We're so glad you were able to join us while we were down there, and we hope everyone here that was able to attend with us had a great time. We look forward to seeing you all in Indianapolis in 2022. If anyone has questions about METALCON, you can always reach out to me. Steve, if people have questions about REINA or Rainscreens, who can they reach out to?
So that number is on your screen, and admin@rainscreenassociation.org is the best place to reach out to right now, and the website is reina.org.
Fantastic. So everyone, the survey link is actually in the chat box here. So please just click that chat box, click that survey, and we'll make sure that you get all the credits that you need for today's session. Thank you everyone for joining us. We hope you had a great time. We'll see you in December on December 8th. Thanks again, Steve. We so appreciate you and Reina's time. Have a good one.
Thank you.